All right, we're going to talk about variations. When we come across variations, they're going to be written something like this. We're going to say y varies. And it might say directly. That might be one adverb they use. It may use the adverb inversely, or it might use the adverb jointly. Okay. The other nice math textbooks might use the word compoundly, but that's not what Hawks will be using. Just in case you transfer or go to another math class, or they don't use Hawks, they use another math book, they might use. Our sentence will say y varies directly as x. The way that we're going to rewrite this is we're going to write y equals x. And one thing that always appears in our variation problems is a k. This k actually stands for a constant. This is what we're solving for in every single problem first. And then we're using that information to know what k is to solve for another equation that they're going to throw at us. Okay. Another statement it might say y varies inversely as x. Now, we set this one up different because we use the word inversely. Now it's y equals, and now because we have inversely, it means this x goes in the denominator now. And we still have our k. Our k is always in the numerator. Okay. And so our last one that we're going to look at is it says y varies jointly as x and z. Okay. Now this one is going to be y equals, and it's just like directly, except jointly means that there's two of these things instead of just one. So it's xz, and remember we always put our constant in our problem. So this is the three ways that we're going to see these variation problems come at us, and this will be our guideline for setting it up. If y is directly proportional to x, and y equals negative 64, when x equals 4, find y if x equals 12. And we're going to round our answer off to the nearest hundredth. So it says y is directly proportional to x. And then it says if y equals negative 64 and x equals 4. Okay, so the first thing we have to solve is what is k actually equal to? What's our constant? So we're multiplying our k times 4, so we're going to do the opposite and divide by 4. And this is going to tell us that our k is equal to negative 16. And so all we're going to do is replug this in. Now it says solve for, or find y when x is 12, right? So now we know our k is negative 16. So we're going to solve it for that. Okay? So we're going to multiply those two together, and we're going to find that y is equal to 184. Correction, it's negative 192. If y varies inversely as x, and y equals 41, when x equals 28, find y if x equals 27. Round your answer to the nearest hundredth, which means 2 decimal places. All right, so it says y varies inversely as x, so that's why we put it in the denominator, and then we always put our constant here on top. Okay, so it said y equals 41, so we replaced y with 41, and it said x equals 28, so we replaced it here. Now we're taking our constant and dividing it by 28. So in order to get rid of this 28, we're going to multiply both sides. So we're going to multiply this by 28 and this side by 28. That causes these to cancel away. And so 28 times 41, it says that our k is equal to 1148. Now, since that's what k equals, on our second problem right here, it says find y when x is 27. And so now we know what our k is, so we can plug it in here. So it's 1148. 48. And so we're going to take that 1148 and divide it by 27. And that gets us a weird little decimal. So that means our y is equal to 42.5. And then we want to close it off at this 1, but we want to know if we need to round it up. So we look to our third decimal, which is an 8, which means that we round that 1 up to be a 2. If y is directly proportional to x squared and y is equal to 278 when x is 18, find y if x equals 3. Round off your answer and there's 100. Okay, so it says y is varies directly with x squared. We have our constant in our problem, so we're going to plug in our y is 278, our x is 18, and so we're going to carry this thing out. So first thing we're going to do is square our 18, which that gives us 324. And this is going to be multiplied times k. So next thing we're going to do is divide both sides by this 324. And this may not be a perfect thing, and I'd like to leave my answers, especially when I'm expressing them as k, if it didn't end up being something nice and pretty, I like to leave them as fractions. And so this is what it would look like as a decimal, but I don't like doing that. So I'm going to turn mine back into a fraction and just leave it. It does reduce. We can divide these both by 2. And so that's where that comes from. So this is 139 over 162. Okay, so now we can plug in our k. So we have our y equals, and then we've replaced our x with this 3 that it says it equals now. And so now we can replace our k with this 139 over 162. Okay, so we can square our 3, which is 9. And then we're just going to be multiplying this 9 times this fraction. Now, the easy way to do this, if you don't have a fancy calculator, is to do 9 times 139 and then divide it by 162. You could actually do it in reverse too. You could take 9 and divide it by 162 and then multiply it by 139. You'll get the same answer no matter what way you do it. And so if we do it that way, we're going to end up getting a decimal. Remember, we got to round it to do 2 decimal places. It's going to be y equals 7.72. That third decimal doesn't make the other 2 round up, so it just stays that. If y is directly proportional to x cubed and y equals 31 when x equals 10, find y if x equals 9. Round off your answer to the nearest hundredth again. I'm going to stop reading that. I think that's apparent that I think we're going to keep rounding to 2 decimal places. I'll read the round off if it's anything other than the 2 decimal places. All right, so we said that y is varies directly as x cubed and times our constant. So we plugged in our y, we plugged in our x, and so we're going to continue to solve this. Now, 10 cubed is equal to 1,000. Okay. And so now we got 1,000 k, so we're going to divide this away on both sides since it's being multiplied by that. So we got 1,000 here and 1,000 here. Now this k is not going to turn any prettier, so I'm just going to leave it as 31 over 1,000. It actually turns out to be not too bad of a number, but it actually ends up being just 0.031. So I'm actually not too afraid to use that. So let's just keep it as 0.031. So let's put that where our k is on this next problem. So let's do 0.031 here. And first we're going to do 9 cubed, which is going to give us this 729. And so then we're going to multiply it by the 0.31. And so that gives us 22.599. Remember, we're cutting it off at 2 decimal places, so it cuts off here, right? This 9 makes this go up to be the next number, which is going to be a 0, which pushes this up to be a 6. So we're going to say that this is 22.60. If y varies directly as the square root of x and y equals 13 when x equals 196, find y if x equals 38,416. Okay, so we got y varying directly as the square root of x. Notice that our k is not in a radical, it's outside of it. Okay. All right, so first thing we're going to do to solve this after we've replaced our letters is we're going to take the square root of 196. Now, to do that, it's going to give us 14. So now we got 14k is equal to 13, so then we're just going to divide by 14 on both sides. And I'm just going to leave it as just this fraction. I think this is going to get pretty awful on us as far as the decimal goes. So I'm just going to leave it that way. So now I'm just going to plug in my k is this. So this goes right out here. So our next one says find y when x is this nasty little number. Okay, so that one I can't really do very well in my head. But I've done this 1,000 times, and I know it's going to be this, but I'm going to prove it to you that it's going to be 196. So the square root of that, so this is y equals 196. And this is times 13 over 14. And so we're just going to multiply times 13 and divide by 14. And it gives us a perfect little answer of 182. If y varies inversely as the square root of x and y equals negative 40 when x equals 400, find y if x equals 160,000. Okay, so y varies inversely as the square root of x, right? We're going to put our constant on top. So we've plugged in our numbers. First, we're going to take the square root of 400, and that's going to tell us that we got k over 20, right? And then we can just multiply by 20 on both sides of our equation. Okay, that's going to tell us that k equals negative 800. And so we're going to put negative 800 on top because that's what our k is now. Now we're going to solve that square root first. This tells us we got negative 800 over 400. And so negative 800 divided by 400 is negative 2. Z is jointly proportional to x cubed and y squared. If z equals 51 when x equals 3 and y equals 7, find z when x equals 5 and y equals 6. Remember, jointly means that we're going to have both of these. They're kind of like directly. It just means that we're looking for two things that we have here. Okay, and so we've plugged in our 3, our 51 as our z. We've plugged in our 3 as our x. We've plugged in our 7 as our y, and we need to solve for k. So first thing we want to do is cube our 3. Now, if you're unfamiliar with doing that on a calculator, you can just do 3 times 3 times 3, but you could also just type in your 3, right? And then you can use this button right here to raise make that little exponent, and then put it to the 3rd power, okay? And that's going to be 27. Now, if we square 7, we get 49. And then we still got our k, so we're going to have to multiply 27 times 49, which gives us 1,323, and that's still times our k. And this equals 51. So to get this off of our k, we need to divide it away. And I don't believe that this is going to... Oh, no, it will. It'll reduce a little bit. So let's see what our k actually equals. It equals 17 over 441. And so now we can plug that in to our second equation to solve and find out what z equals in our second equation, which is what we're looking for. So we're going to do 5 cubed, which is 125. We're going to do 6 squared, which is 36. And we're multiplying it times this fraction, our constant. Okay. So we're going to multiply all these things together, and it gives us a funky little decimal, which is what z is equal to. And we have to round it to 2 decimal places, or 100th place, right? Once again, this 9 makes this go up to be a 7, so it's going to be 4, 7. Z varies directly as x and inversely as y. If z equals 123, when x equals 6 and y equals 6, find z if x equals 7 and y equals 8. Okay, so this one's kind of interesting. This is when it starts to get a little bit fun, because now we've got a directly in our problem, and then it says that y varies inversely as this. So directly and inversely, we know where to put them there. We got our constant in our problem. So it says that we plug in x is 6 and y is 6, and then our z is 123. Now, when we start this problem, we can just do 6 divided by 6, which gives us 1, right? That actually gets rid of our 6's and just says that this is what our k is equal to, is 123. So really, we're just going to have to plug in 123 as our k when we do this second equation. So we're just doing 7 times 123, and then we're dividing it by 8. And so this gives us that z is equal to 107.625, right? We cut it off right here, so that 5 makes our 2 go up. So this is actually 107.63. Z varies directly as the square root of x and inversely as y squared. If z equals 240, when x equals 81 and y equals 3, find z if x equals 25 and y equals 7. It said that z varies directly as the square root of x and inversely as y squared. Okay, so we're going to plug in our numbers, z being 240, x being 81, and y equaling 3. So the first thing we're going to do is simplify this one. Square root of 81 is 9. And the square of 3 is 9. Once again, these 9's cancel each other away, and we found that this 240 is actually equal to our k. It actually equals 1. 9 divided by 9 is 1, so it's one of these k's is equal to 240. So now we can just plug in our 240 as our k in our second equation. Now this one said our x is 25 and our y is 7. So we want to take the square root of our 25, which is 5, and we're multiplying that times 240. And then we're taking the square of the 7, which is 49. So now we're going to do that. So 240 times 5, and then we're dividing it by 7. Now this gives us a fun little decimal. So z is actually equal to 171.4, and we're going to take this 2 right here, And because that's an 8, we're going to round that up to a 3. Oh, check that. I had divided it by 7 instead. I wanted to take this 1200 and divide it by 49. And so instead that gave me 24 point, and this 9 makes this 8 go up to a 9. So this is 24.49. The gravitational force F between an object and the Earth is inversely proportional to the square of the distance from the object to the center of the Earth. If an astronaut weighs 229 pounds on the surface of the Earth, what will this astronaut weigh 400 miles above the Earth? Assume that the radius of the Earth is 4,000 miles. Round off your answer to the nearest pound. So we're not doing decimal places this time. We're actually rounding off to the nearest pound. So we want to cut it off before we even get to a decimal place. Okay, so this is the way we're looking at it here. Okay, so it says that from the center of the Earth here, right, to the surface, the distance from here to here, that's going to be 4,000 miles, right? And so that's why I've put that as our distance here. That's what goes as our distance. The force is measured in pounds, and so we're going to continue to solve this. Now, we need to square this 4,000, which gives us a pretty astronomically big number. So this is K over, and this is going to be 16 million is what we end up with here. Multiply 4,000 times 4,000. Okay. And now to get this out of the denominator, because that's what we're dividing K by, we're going to have to multiply by this 16 million on both sides. Okay. And so this gets multiplied by 16 million. So 229 times 16 million tells us that K is equal to and that's 3,664,000,000. Okay, so that's what we're going to plug in is our next K. So now we're looking for our force again. We want to find out how much it is. Now this astronaut has gone out and he's 400 miles away from the surface of the Earth. Now, just to get from the center to the surface, that's 4,000. And so we need to go 400 more. So the distance that we're looking for in our denominator is 4,400. Remember, we're going to square that. Okay. And now this is all over 3,664,000,000. Okay, so let's do this 4,400 squared, which is going to be a pretty big number in itself. That turns out to be 196,300. Okay, so that turned out to be 19 million, and we need, we're going to divide that 3,664,000,000 by that. So that divided by that gives us an answer where our force is equal to 100. And this 2 doesn't make this round up. So this is just going to be, this astronaut is 189. And you can see that as he gets away from the Earth, his pounds of pressure start to decrease. And so you can see his weight went down. And that makes sense by our logic. The distance that a free-falling object falls is directly proportional to the square of the time it falls before it hits the ground. If an object falls 70 feet in 4 seconds, how far will it have fallen by the end of 9 seconds? Leave the variation constant in fraction form or round to at least 2 decimal places. And then it says round your final answer to the nearest foot. That's one thing I like to do, is just leave it in fraction form if I can. Now, first thing we're going to do, right, this is it says it's our distance is equal to the square of the time it takes to reach the ground. Okay, so plug in our constant here. Our distance is 70 feet. Our time was 4 seconds. So first thing we're going to do is square that 4 seconds, which gives us 16. That's 4 times 4. And then we're going to divide both sides by 16. And so we're going to leave this in fraction form. And so this k is equal to 35 over 8. And so let's plug in our k and solve this equation again, now that we know what our constant is. Okay, so it's asking for the distance when this object is fallen for 9 seconds. So we're going to square our 9. That's equal to 81. And now we're going to multiply this times 35 and divide it by 8. And so it says it's going to fall for 354 feet. That 3 does not make that 4 round up. The length that a hanging spring stretches varies directly with the weight placed at the end of the spring. If a weight of 7 pounds stretches a certain spring 5 inches, how far will the spring stretch if the weight is increased to 40 pounds? Leave the variation constant in fraction form. Round your final answer to the nearest inch. All right, so the first thing we're going to do is plug in our length, which is 5, our weight, which is 7 pounds, and then we have our error constant. So we're going to divide both sides by 7, and then just leave this in fraction form. So this k is going to be equal to 5 over 7, because these will cancel. So we're going to go ahead and plug in our k, which is 5 over 7. And our new weight that we're putting on this spring is 40 pounds. So we're going to see how far that stretches it. So we're going to take 40, multiply it times 5, and then divide everything by 7. And so we get an answer where our length is 28. This is going to be 29, and it said that wants us to round to the nearest inch. So should be 29. The lifting force F exerted on an airplane wing varies jointly as the area, which we're going to call A, and the wing surface of the wing surface, and the square of the plane's velocity, which is V. The lift of a wing with an area of 250 square feet is 37,600 pounds when the plane is going 100 miles per hour. Find the lifting force on the wing if the plane slows down to 90 miles per hour. Leave the variation constant in fraction form or round to at least 5 decimal places. Round off your answer to the nearest pound. So our equation looks like this. Our force is varies jointly as our area, the square foot area of the wing, and then the area, and then the square of the velocity, and then we got our k in our problem. So force usually occurs in terms of pounds. We had that happen with our astronaut weight problem, but that's what we got here. Our area was 250, and then it says our plane was going 100. Okay, so we're going to square that. So first thing we're going to do is square that, and then we're going to multiply it times that. So we should get 37,600 equals, and this is going to be 50, and then we got k. So this is 2,500,000. Okay. And so now we're going to divide both of these by this 2,500,000. And get what our k is equal to. And so I'm not going to turn this back into a fraction. I'm just going to leave it as this because it turned out to be a decently working decimal. In fact, it says use 5 decimal places, and this is exactly what it has. So I could turn that back into a fraction if I wanted to, but this is perfectly fine to use in our problem. So the first thing I want to do is square my 90, which is going to be 8,100. And then we'll multiply all these things together. It really doesn't matter what order I multiply these things in. So I'm just going to take it from this 1504, then I'm going to go to the 8,100, and then multiply times 250. Just do it backwards. And so it says our force is now 30,456. Now, this 90 miles an hour meant our plane slowed down. So this should have decreased, and it sure did. Because if we're slowing down, it decreases our pressure on or the force on our wings. So this is what we're looking for. So 30,456. The resistance R of a wire varies directly as its length and inversely as the square of its diameter. If the resistance of a wire 4,100 feet long with a diameter of 0.11 inches is 7858 ohms, what is the resistance of 33,000 feet of the same type of wire with a diameter of 0.06 inches? Leave K in fraction form or round to at least 3 decimal places. Round off your final answer to the nearest hundredth. Okay. So in our problem, I'm not going to go away just yet and tell you anything, but when it says that thing is 7,858 ohms, that is our resistance. So that's what we measure resistance in. This says our resistance is equal to, or is jointly equal to our length, and inversely is our diameter squared, the square of our diameter. Okay. So like I said, that ohms was at 7,858. That's our resistance. The length was 4,100 feet, and the diameter was 0.11. Okay. So the first thing I want to do is square this 0.11, and that gives me 0.0121. And so I'll plug all this stuff back in. Now, other math teachers might do something different here. I like to take it real slow through this stuff. And that way you really know. Because other math teachers would tell you that you're going to multiply this fraction times its reciprocal, and you can do that just fine. But just for people that like to take it slow, I'm going to say to get rid of this, we're going to multiply this by 0.0121. And we'll multiply this one by 0.0121. And so that gives us 95.0818, and this equals 4,100. Okay, so we're going to divide both sides by 4,100. And this gives us a crazy decimal. And it said, I'm not sure how many it said to keep it to, but I'm going to write quite a bit just because and it doesn't say that we can even turn that. See, even I tried to turn this back into a fraction. To do that, you can hit math, and there it is. It says turn this thing back into a fraction, so I didn't enter and enter again. Okay, but we're going to get out of here. And so we're just going to say that our k is equal to this. And I might even write this whole thing down. Feel free to do something like that. But it did tell you how many it does want you to keep this into. And it's saying this. That way when you round it, you do get the same answer. But it doesn't matter. We can be overzealous and write down every bit of our decimal. Okay? So I'm just going to write that this is still our k, but we're going to reference down to this one when we do it. Okay, so just know that's what's going to happen there. It's not still k, it is this number. So we're going to see what that 0.06 is first, squared. And so this r is equal to 3,300. And then this k number that we have down here, right? And this is going to be divided by 0.0036. So let's do this 3,300 times, and if you've done this on this calculator, you can just go grab this number up here and then multiply it. And then say we want to divide it by this number here. And so that gives us what we're looking for. So it says our resistance is 21,258. I think it said round to the nearest hundredth. So this 5 right here makes it round up to be 0.13. The safe load L of a wooden beam supported at both ends varies jointly as the width W and the square of the depth D, and inversely as the length L. A wooden beam 3 inches wide, 3 inches deep, and 18 feet long holds up 1,355 pounds. What load would a beam 4 inches wide, 8 inches deep, and 17 feet long of the same material support? Round off your answer to the nearest pound. It says that our load is varies jointly as the width, the depth squared, and our length. Okay, and then we plug in our constant here. So our load is always, that's pounds as well, so that 1,355 pounds, that's there, 3 inches wide, the depth of 3 inches, and then our length is 18. So we're going to go ahead and multiply these out. This is basically just 3 times another 3 times another 3. This is going to be 27, because that's 9 times 3 is 27. This is k over 18. And then we got 1355 still on this side. Now I want to get rid of this 18, so I'm going to multiply by 18 on both sides. Okay, and so that cancels that away. And if I'm doing 18 times 1355, that gives me 24,390. This equals this 27k. And then I'm just going to divide both sides by 27. And it doesn't give me a pretty number. In fact, it just reduces down. We can divide both these by 3. And so our new k that it's going to be equal to, and I'll write it right here, is 2710 over 3. And so that's what our new k is, 2710 over 3. So we're going to go ahead and multiply this, plug in our numbers, our new numbers. And so 8 squared is 64, and then 64 times 4 is 256. So we get L equals 256. And we're multiplying this times 2710 over 3. And then we're going to divide all that by 17. So on our calculator, we got all that stuff here. So we can do this one times this one. And then we can divide this all by 17. And this tells us that our load is this 13,603. Our 1 makes that 3 not do anything. It still stays this 13,603.
That's all, folks.